Welcome to the topic on Riemann sums and rectangular approximation methods. Let's explore how left and right Riemann sums work, how they use rectangles to approximate the area under a curve, and the differences in accuracy between them. Let's get started. A Riemann sum is a method for approximating the total area underneath a curve on a graph, otherwise known as the integral of a function. The area is divided into smaller segments, often rectangles, whose areas are calculated and summed. The left Riemann sum uses the left endpoints of the subintervals to calculate the height of the rectangles. The more rectangles used, the more accurate the approximation. By aligning the rectangles based on the left endpoints, we capture the area under the curve from the left side of each segment. Now let's explore the right Riemann sum. This method utilizes the right endpoints of the subintervals to determine the height of the rectangles. Similar to the left sum, increasing the number of rectangles enhances the accuracy of the approximation. This approach provides a different perspective by considering the area from the right side of each segment. Comparing the left and right Riemann sums, we observe that their accuracy relies on the behavior of the function and the number of rectangles used. Depending on whether we need an overestimation or an underestimation, choosing between left and right sums becomes crucial. Understanding this comparison helps in selecting the most appropriate method for specific scenarios. As we increase the number of rectangles in both left and right Riemann sums, the accuracy of the approximation improves significantly. Visualizing this increase in precision showcases the power of using more rectangles to capture the intricacies of the curve and obtain a more precise estimation of the area beneath it. Riemann sums play a vital role in calculus and applied mathematics. They serve as a fundamental tool for visualizing and computing definite integrals, enabling a deeper understanding of complex mathematical concepts through practical approximation techniques. Now, let's engage in a brief quiz. 1. What is the fundamental difference between left and right Riemann sums? 2. How does adjusting the number of rectangles influence the precision of the approximation? 3. Can you provide a real-life example where Riemann sums are applied?